Hi friends, today we will make the simplest spotter. The idea to develop a circuit for the most budgetary spotter was for a long time. A while ago I published a couple of videos with the assembly of contact welding machines, but I hadn't time to make the full functional and powerful spotter. I must say that in this video I will talk about the principle of the circuit, the choice of accessories, and other details related to the device. But the tests we will do in the following videos, as for the operation of this unit I need to buy a car accumulator. So, at the beginning, let's understand what a spotter is and why it is needed. A spotter is a device for contact welding, but not only. Particularly, it is used for bodyworks of cars when it is necessary to straighten something. The device consists of three main parts: a power transformer, an electronic contactor with a timer, and electrodes. A high-power transformer, which usually works from mains, gives a giant current. This transformer is controlled by a timer, which switches it on and off for a certain time. One of the power terminals of this transformer is connected to the body of the car. It's a mass or ground. The second is working electrode. Its tip must be connected or pressed to the center of the section, which needs to be straightened. The timer starts the transformer, and in fact we get a short circuit on the area of the car body. A short circuit causes heating, and the working electrode will partially weld to the body. With gentle movements, the master repairman pulls out the stuck electrode, which pulls the damaged area of the car body. The time of the welding must be carefully monitored, otherwise the body can get a hole. As a matter of fact, the spotter is a controlled switch which connects and disconnects strictly for a given time to turn on and off the power supply. It can be said that my version of the spotter will be portable. For its operation, no main transformers are needed. The power is taken directly from the car battery. It is connected into the break of the minus or mass of the battery. This is my circuit. It consists of a timer and a contactor assembled on the powerful field transistors. Let's analyze the principle of operation of the circuit. A timer is built on the chip NE555, which is started by pressing the button SA1. On the transistors VT9 and VT10 is assembled a complementary emitter repeater. Its function is to amplify the output signal from the microcircuit. In fact, it is the amplifier of the current. I will not explain how works the emitter repeater. There are a lot of articles about working of transistors. In fact, here working only the upper transistor. When the button is pressed, the positive signal from the output of the microcircuit NE555 goes to the base of the transistors. The upper transistor will open, and through it, the pulse from the low current source goes to the gate of the field effect transistors. A positive signal opens the FETs, and through them the main power voltage from the batteries goes to electrodes. The lower transistor is designed for the instantly discharge of the FETs, gates to the ground, thereby ensuring their reliable closing. It is better to show the work of FETs on a live example. For this we use the oscilloscope. When you press the button, you see the peaks. They are the moments when the FETs are triggered. In other words, this whole circuit is nothing more than a controlled timer, which simply short-circuited the battery to the welding point for a short time. Field effect transistors in our circuit operate in a rather hard mode, although the work is for very short time. Instantly, the currents of several thousand amperes flow through them, and it is very important to provide a smart control. This circuit is perhaps the simplest and most reliable method of control. In the first video, I mentioned this, but I will explain again just in case. In the circuit we have two power supplies. One of them is the power unit. The other is needed for the correct and stable operation of the control circuit. As a low power supply unit for the control circuit, a 9-volt 6F22 battery can be used. The design is assembled on one printed circuit board. There is nothing complicated in manufacturing of this particular PCB, but we are planning to release a small trial lot of such devices on the factory-made boards, which will be ordered from our partner GLC PCB. This is a large factory which has been on the market for 10 years and is specialized in the development of industrial printed circuit boards by our drawings. The price of the board starts from $2 for 10 pieces. Free shipping is available for the first order. Link to GLC PCB can be found in the description. Power tracks on the PCB are additionally reinforced with 3 mm copper wire. All field effect transistors are screwed to the duralumin bus, which is both a radiator and a power current carrying contact. Transistors are screwed to the bus without gaskets. Even thermal paste doesn't need, as it will degrade electrical contact. The FETs will be in operation for a very short time, and the heat is perfectly dissipated without thermal paste. I have used powerful FETs IRFP1404. For a short time, each transistor can commute currents up to 800 amperes. In our circuit, they are as many as 8. Theoretically, the maximum switching current of circuit can reach up to 6,500 amperes. But the fact is that I bought them at China, and I am not sure that they will not explode at the first start of the circuit. By the way, I haven't tasted the circuit yet. As the power wires, I use standard aluminium of 25 square millimeters. Unfortunately, they are aluminium, but some plus is that they are rather soft and easy to bend. The big cross-section is the best option. Don't forget that at currents of 1000 amperes or more will increasingly losses on the wire resistance and producing too much heat in the conductors. This reduces the overall efficiency of the circuit, so we need thick wires. Exactly the same kind wires are completed with many welding inverters, but in our case the currents will be much greater in the arc welding, although they will take a very short time. Conventional brass terminals are connected to the wires for connection to a regular car battery. I will remind you again that our circuit is switched minus of the power supply, that is, the plus from the accumulator directly goes to the electrode. Friends, this concludes the first part of the video about the spotter. Let me remind that references to the past videos with the process of assembling contact welding machines will be found in the description. Also, there are links to PCB, circuit, and to all components for assembling this unit. When I will buy a car accumulator, we will see what our device can do. Don't forget to subscribe to our group on Facebook to stay updated of the news. Now I have to say goodbye until new meetings. With you was Kaisian TV.